I'm sure. Hi, Parvini.
Hi, Auntie. How are you?
I'm good. You know what? Is Krish not coming? What is going on with the class? 1 second, ma. We can get started, but I really want. I don't know what is going on with Krish. Let's see. I remember putting a copy to him. Krish Choksi. Yeah.
Not really.
Oh my god, they didn't receive the email.
I don't really care.
AB Calc. Oh, did I not send a welcome email, ma?
I got it.
Oh, he's there. He's coming. I saw him. Okay, I feel like I sent it. Okay. I just want to make sure who all I sent it to. Parvini, Krish. Yeah, and Mana. Okay, Mana will come later. That's fine. Okay, we'll get started. Hi, Krish. How are you? Nice to see you after a week break. After 2 weeks of break, right?
Yeah, I'm doing good. How are you?
Good, ma. So, you're only doing AB Calc, right? Both of you?
Yeah.
Shall we go ahead? Okay, you know what? Krish, were you there for the class where we discussed limits?
Yeah, I'm pretty sure.
Do you remember? A
Kind
little,
of.
a little.
Yeah.
Okay, we'll go over that. Basically, what I plan to do is I'll go over that 100%. We will concentrate on limits this week and next week. Okay, so basically, how we are going to do that? It's important, okay, because I think 12 MCQs are coming from this section directly. Okay, so you should have a basic understanding of what limits are, how to calculate them graphically. You need to be able to calculate them from a table. You need to calculate them, or analytically, if you're given an algebraic expression, you should be able to calculate limits. So that's the intent. Make sense? Okay, so let's go ahead. um 1 second, ma. What did I want to do? Let me share my screen. We'll start from the first. Are you able to see? What is going on? Are you able to see my board? I don't know what you're able to see. Wait. Yeah, I can see. Something you're not seeing. I can see some mess going on. Hold on. You're able to see now? No. Hey, guys. 1 minute, guys. I don't know what is going on. Hold on. What is going on? For the first time, I'm not able to share with you. I don't know, ma, honestly. Okay, wait. Oh, there are so many. Oh, okay, I see. That's the deal. Okay. Now we should be able to. Let's move on. Give me 1 second. Let me share this with you. Yes. Yes, you're able to see, right?
Yeah.
Yeah.
Okay, good. Okay. You have come across limits a little bit in algebra too, right? So it'll be full of limits now. Let me get out the notes that I have prepared for you. Limits. So first we'll go to graphical limits. Okay, that's good. 1.1. Yep. Okay. define limits. Let's see. So limit is the y value of a function. The y value of a function, what it approaches, okay, from both the left and right of a given x value. Suppose let's say we have a function like this. This is the x equal to 5. Now, what is limit? How do I define the limit? It's the y value a function is trying to approach. Limit means it is trying to approach. Let's say limit at x tending to 5. If I ask you at 5, the x value, what is the y value it is trying to approach? It doesn't have to be the exact value. You see, that is the limit. Okay. Suppose if I ask for f of 5, right, you will directly give me this value. Okay. Suppose if I give, this is the notation, guys, limit x tending to 5 f of x. This value might be different from this value. This is directly the function's value at f is equal to 5. Okay. Suppose let's say a function is like this. Yep, like this. That's a good one. This is still a function, guys, because it passes the vertical line test, all this stuff. However, when you look at it, right, let's say this is 5, okay, this is 2, this is 4. Now tell me, what is f of 5? What is the function's value at f is equal to 5? You tell me by seeing this graph.
2.
Not really. At 5,
Oh,
what
is it undefined?
yeah, this one is an open dot, right? This is 4. Makes sense? The function's value at f is equal to 5 is 4. However, I'll talk about limit. Limit is when the x value is approaching 5. X value is approaching 5. What is the function's value? That's what it means. What is the function's value when the x value is approaching 5? When the x value is approaching 5, what is the function's value? Is it 2? Make sense?
Yeah.
Yeah.
Okay. Now, the thing is, this is very easy now. You know what a limit is. Basically, it's the approaching y value at that particular x value. That's what it is. But in limits, right, as we move up, right, we are in AB Calc. So it's going to be a little more in depth. When you talk about limits, right, we will also be talking about left limit and right limit. What is this left limit, right limit? Okay, this one I'm going to expand it. Limit x tending to 5 minus. Limit x tending to 5 plus. Do you see? What does this mean? See the notation, guys. Notation is very important. Don't make a mistake writing it out there. Now, this, as I said, read it out, right? The function's value as x approaches 5, I said. However, I split that into left limit and right limit. What is this left limit? Let's show. This is the left limit. Okay. What is the right limit? Right of 5. Make sense, guys? Okay. Now, the thing is, if I ask you about limit extending to 5 minus, means you have to think about a little less than 5 is what you need to think about. When x is a little less than 5, that's what we'll think about for 5 minus. What is the function's value when x approaches a number little less than 5? What is that? Let's say 4.999. At that point, what is the value of the function they're asking? Can I call it as 2?
Mm-hmm.
How about this? Can I call this as well as 2?
Yeah.
Yeah.
Okay, so here the left limit is equal to the right limit. Many times they may not be equal. Okay, suppose I have the same function. Let me draw. I'm just drawing my own function, okay? Let's see. Suppose if there is a function like this, same I'm going to calculate f of 5. Okay, I'm not changing anything. Okay, let's have the same 2, but it's slightly different when you look at it. This function is different from that function. So now what is f of 5? Is a 4. You all agree with me?
Yeah.
Yeah. So this class will contain another one boy. Okay, meaning I have tried to BC. I said I'm not going to because I cannot keep on accumulating classes, I felt, guys. So I just took up only AB because Krish mom and Parvini has been asking. So similarly Manoj's mom was asking as well. So I just took up AB, BC. Shri was taking BC. The other girl, there were other two girls, right? They're taking IB curriculum. That because again it's completely different set of scope of whatever we need to discuss was different. They all sent me the curriculum. I did go over. That's easier actually. The IB one was easier than the calculus though. But since I promised to you guys, okay, I thought I'll take up the AB this year. Makes sense? So we'll continue only with AB, okay? So here, let's go over this. F of 5 again is 4. I just wanted to let you know, that's all, okay? Then let's do the left limit and right limit, okay? Limit extending to 5 minus, oh, I'm sorry, what I'm doing? 5 minus f of x. What is it? You tell me what is the right limit. You guys tell me.
Is the left one 2 and the right one 4?
Correct, guys. You got it?
Yeah.
However, there is a catch here. Just because the left limit and right limit were equal, we said limit extending to 5. Right smack at that point it's a 2, we said. Okay. But unfortunately in this graph, the left limit and the right limit are different. So limit extending to 5 f of x, what is it you think?
Is it undefined?
Yeah, does not exist. Makes sense, guys?
Is there a difference between writing does not exist and undefined?
Is there a difference between does not exist and undefined? Yes. In my opinion, yes. And in mathematical opinion, yes. Does not exist is not the same, but I just want to confirm. Both are very different. Why? I just want to verify before I say that. C are not the same. What I thought was correct. I just want to verify because I don't want to commit and make a I don't want to misguide you. See, the thing about undefined and does not exist is undefined, when does it come into picture, Krish? Whenever something is divided by 0, right?
Mm-hmm.
That is when you say undefined, meaning the mathematical operation of dividing by 0 is not defined. That's what we say, right?
Yeah.
Whereas does not exist means it does not emerge out to be a concrete value. It is not a finite number. That's when you say does not exist. Does not exist exclusively, you can see it only in limits related calculations. Undefined comes up when a division by 0 is encountered, or if there is an operation that is impossible to be done, meaning, see, division by 0 is not possible. That's what every time we say. It's an impossible operation. It's not defined in mathematics. That becomes undefined. Does not exist means no, we are not able to arrive at a concrete value. You don't have an answer to it. That's all. You got it?
Yeah.
I want to give you some wait. Wait, let me see. Yeah, we can look at 1 or 2 examples. Okay. Yeah. When I come to removable discontinuity, I'll be able to explain to you more the difference I feel. Let's see. Let's see. I'll come back on that, okay? Now we understood when the left limit is not equal to the right limit, the limit at that particular point does not exist. Have I made it clear to you guys?
Yeah.
Okay, so that's the point that we are going to carry through. Okay, now I'm going to ask you a couple of questions. Here, you're going to do it by yourself. This one is easy, guys. Let me erase whatever is on the board. So here, if you will, yeah, we'll try to follow from day one, guys. Okay, after that we don't have to suffer so much. How about this? Can you tell me what are the values of these? f of minus 3, everywhere. In each of the graph, what is f of minus 3?
Miss Priya, you want us to send it in the chat?
Yeah, go ahead. No, go ahead. Only see, it's a small class, so I just want to go ahead. Go ahead.
It's 4.
F of minus 3.
Undefined or does not exist.
F of minus 3. F of minus 3 is undefined. Keep going, keep going. Only in limits we say does not exist. You see, huh?
Okay.
When it is limit related answers, does not exist come into picture, okay? Whereas undefined means, see, there is a hole here. The function's value, what is the function's value at minus 3? It is undefined. It's not defined in the graph at all. Here, what is f of minus 3?
1.
1, correct. F of minus 3?
1.
Correct, 1. Here?
2.
Correct, mark. Very nice. Okay, great, guys. We got it. Let's keep moving. So basically we are only discussing limits from a graph now. It'll move fast. Let's see. What did I want to say? How about this? It's a good one. Okay, how about this? Extending to. I really want to cover extending to. Let's see that. Did I erase it? That's, did I erase that? Can it come through? Oh my goodness. Sorry, guys. So I really want to f of minus 3, f of minus 3. Okay, this is what we had, right? We did discuss about f of minus 3, f of minus 3. This one we discussed. Okay, that's great. Now, what I really want you to tell me, one more thing I want you to tell me. This one. Can we try this one? How about that? First, what is f of minus 3 here? You all said it's 4. This one you all told me. This is undefined. This one is a 1, right? Limit extending to minus 3. What it is? What is it here? Extending to minus 3.
4.
Is a 4. Correct? Limit extending to minus 3.
4.
4. See? The limit is, you have a value, but the function's value is not defined. Extending to minus 3, f of x.
Does not exist.
Huh?
Does not exist.
Why, ma?
Is it 4?
4, right? See the left side and the right side of that point.
Oh, yeah.
It is trying to reach 4. You got it? Okay. Okay. One thing what I want to point out to you is, you have heard of the square root of minus 1 now? What is the square root of minus 1?
I.
I. But over the domain of real numbers,
Uh,
over the if I ask you what is the square root of -1 and I only consider the domain of real numbers, then can I say it's undefined? It's not defined within the domain of real numbers, correct?
mhm.
However, however, it's undefined in the domain of real numbers. But does it exist? Yes, it does. It does exist when we get into complex numbers. Make sense?
Yeah.
So here, this undefined cannot be replaced by does not exist. No, you can't do this. You got it? Yep. So that's one difference. You cannot substitute one with the other. Okay. Now you understood this. I'm going to move on. Okay. I've told you about the one-sided limit, right, guys? One-sided limit is what? Is the value on the y-axis for a function as it approaches the given x value from either the left side or the right side. Does that make sense? Okay. Now I'm going to give you this and ask you some questions again. Have calculator with you always, okay? So, do you think you can do this one? No, I want you to try, right? I want you to try. I don't want to give the answers here. Can you try? Guys, try. What do you think this is? You can shout out. Mano will come next class. You go ahead. I'm open, guys. To give it a try.
Um, for the first, then to the left side, it's -1.
Left side it is 3 minus. It's a -1. Good job. The second one?
Is it 2?
2. Correct, ma. Oh, I think you guys got it nicely. Okay. Okay, how about this? Shall we do one full set again? It's a little confusing, but that's okay. Let's see. You can really use the 8 weeks to get a good head start, guys. And finally, f of 1 also I need, okay? As a j part, what is f of 1? Can we try this one? You tell me. Meaning, we'll fill in and keep moving. This is a little tricky. When things are given like this, it becomes tricky. Limit extending to 2 minus. What is... Oh, minus 2 minus. Okay. You tell me, guys. I'll wait.
Is it 1?
Good, nice. Then B. Limit. Yeah, I don't know. Read. You tell me. Krish, why don't you tell me? B and C.
For B, wait, -2 on the right. Is it -2?
Correct. C, you want to say Parvini?
It does not exist.
Correct. D. One of you tell me.
Is it -2? Oh wait, no, it's 1.
1 is correct. E.
-2.
Correct, ma. F. F is
5.
hmm?
F is
5. Good job. G. 5 is correct. G.
Is it -3?
Correct. H.
Is it 0?
Correct. I.
1.
J.
-2.
Correct, ma. Okay. Now, when does a limit does not exist? I'll tell you. Okay, there are three scenarios. Scenarios where a limit does not exist. Okay. One we already discussed. Left limit is not equal to the right limit. This is one important piece that we already discussed, right? The other one, if there is a vertical asymptote. See, let's say you have a graph like this. Now, at x equal to 0 or x tending to 0, right? The limit will not exist. Now, the last pointer where the last is oscillation. When there is oscillations, what is oscillation? What is this function? You see, this is sine cos function, right? So when it is oscillating, right, this is oscillating between -1 and 1. When you think about it, when it goes to minus infinity, it can be a +1 or a -1, right? So when there are oscillations, the limit will not exist. Okay, oscillating behavior at a particular x value means the limit will not exist. Any questions here? Can I move on? Okay. Now, if I give you this, do you think you can draw a graph? This one I did discuss last class, okay? It's okay, but I know that you might not remember this, and the intent is not for you to remember as well. I just want to see where we are. Can we try? Let's see. Maybe Krish will remember a part of it, is what I think, because I remember discussing with you. Let's see. How about this? Shall we try? Can I see your graphs? Sketch a graph of a function g that satisfies the following conditions. G of 3 is a -1, limit extending to 3, meaning the left side of 3 should tend to a 4. The right side of -2 should go to a 1. Then the function has to increase in its y value from -2 to 3. And the left side of -2 is greater than the right side of -2. Can we try? Your answers can be very different. They need not be the same at all. You need help, you'll have to bug. Got it? Your function can be any way, meaning you won't have the same answer. You're able to get it?
I'm not sure how to do the part E.
What is it now?
I'm not sure how to like make the graph including part E.
Oh, really? Okay. My answer can be different from what you guys have. If you can show me, I'll verify, okay? But this is how I would go ahead, okay? G of x is what I want to draw. G of 3 is a minus 1, so that is a minus 1, okay? That's great. And then limit extending to 3, G of x will be a 4. Limit extending to 3, G of x will be a 4. So basically G of 3 we already defined, but here I can't put G of 3 as a 4, but then it has to tend. Tend means I'll put a hole, then it goes like this, it comes out from there. Because that's what I can do. Left limit, because see, limit extending to 3 exists. Exists means left limit is equal to the right limit. Left side of 3 should go to a 4, right side of 3 should go to a 4. So this is done. Minus 2 plus. Minus 2 plus means right side of 2 is tending to a 1. Right side of 2. Okay, right side of 2 is tending to a 1. I can have it like that, right? Now the last one, G is increasing between minus 2 and 3. G is increasing. By default it's increasing. Do you see? This is minus 2, right? This is minus 2, right? Minus 2 is a 1. But whereas, see, G is increasing on means minus 2 is a 1, and then G of 3. G of 3 is what? Oh, that's incorrect. Wait. G is increasing between minus 2 and 3. G is increasing between minus 2 and 3. Yeah, it is increasing. G of x is increasing between minus 2 and 3. This is what Krish, did you say D was hard or E was hard, Amma?
E. I wasn't sure what to do for E.
E. Okay. G is increasing between minus 2 and 3. Okay, let's see. Yeah, it is increasing between minus 2 and 3. Yeah, that's okay still. It is increasing between only is given. So I can connect this with this, like this. And then minus 2 minus is greater. Minus 2 minus is greater means it's like this. From up it's coming down. Minus 2 minus. Left side of minus 2 is greater. See, y value is greater when you think about it. Do you see? Is greater than is greater than 2 plus. 2 plus, see, is greater than 2 plus.
Okay.
You got it?
Yeah.
Okay.
Miss Priya,
Yeah, Amma?
I didn't get the.
Wait, let me see, Ma. You didn't get what? Which one?
E.
Limit at 2 minus, it is greater. Okay. 2 plus will be lesser. But mine, does it show that? No. Okay, so I will go ahead and do this one, Krish, for that. For me to clearly show that, right? See, each of our graphs may be different. Okay. The minus 2 minus will be at a greater value. So why can't I do this clearly to show that? Minus 2 minus, it will be at a greater value. The left limit will be like this. This is minus 2, right? So it is coming from a bigger, higher value. Whereas minus 2 plus will be a lesser value. I can do this, right? 2 plus. Does that make sense?
Yeah.
Can I have it like that?
Yeah.
Krish, did it make sense?
Yeah.
See, and between minus 2 and 3, it is increasing. Does that make sense? And at 3, what happens? There is a value of minus 1, but limit is tending to 4. Does that make sense? Everything is obeying. Parvini, which one are you not getting?
I got it.
You got it? Okay. It's just that you need to reread the problem. You'll be able to finally sketch it out. Okay. Now, okay. So you drew this, but there was one more problem that I want to do, and I don't see that. Why? I really don't see that. Let me see guys, where am I mistaken? Yeah, this one. Oh my goodness. Okay, how about this? Would you be able to do this, you think? Yeah, this one. Would you be able to do that, you think? Somewhere I messed up. Okay, AB Calc 1.1. Okay. Yeah, go ahead. Would you be able to do that? You want to say or you want me to say? Anything works with me, please, guys. It's a small group. I really want to do properly. Let's see. You can shout out or you can ask me to shout out, but I really want inputs from you guys, please.
We'll try.
Yeah, please. Go ahead. Nice, man. Go ahead. If we finish this limits, it's wonderful today. Go ahead.
Is A true?
Yeah, that is true. Then this one. Krish, you want to say?
Is that one also true?
Correct. This one. So 1 minus means what? 1 minus left of this. What does it say? 1 minus, that's equal to 1. What about that?
Is that true?
True. Good. 1 plus what happens? Tends to 2. What is that?
True.
True. This one? Good night.
That's true.
0 minus? What happened to 0 minus? And 0 plus, are they equal?
Yeah.
Yeah, 0 minus and 0 plus are equal. How about this? X tends to 2. Tends to 2 means?
That's false.
Yeah.
True or false?
False.
False.
Yeah, false. It does exist, right? Because left limit is equal to the right limit. It does exist. You got it?
Yeah.
Okay, cool. Nice one, guys, from the graph. Let me, okay. So, the basic examples that I wanted to do in class is done. Okay. However, one second, let me see. Okay. What did I want to ask you? I wanted to ask you a few questions. Okay, the example problems are done, but wait. Limits in a graph. Okay, maybe see. Okay, rather than this you do it at home. Okay, we'll go to test prep like AP exam, right? What type of questions you will get? I did consolidate them and keep it for you. You're okay? 1 second, guys. 1 second, please. Okay, let's go to the test prep questions that I consolidated. Okay, let's go here. Okay, this one I want you to be able to say. Okay, let's see. Let me put it out to you. You're going to answer the questions. If you don't know, then I'll help. Okay. So the graph is here. You want a bigger graph, right? Yep. Here we go. Why? Okay, that's the graph. I just want you to tell me. Oh my gosh, but just because I made it bigger, I'm not able to cut paste. Okay, so how about this? How about this? Okay, guys, the graph is given. Okay, the question is which of the following statements about f is true? You want to do it by yourself?
Yeah.
Okay.
Fine. Just send the answer. Send the answer or you can shout out. If both of you differ, that does not matter to me. We can discuss. We are just learning.
I sent my answer. One second. You send the answer to me. Okay. Did you send them?
Yeah, I also sent.
Yep.
Oh yeah, you guys are amazing. Okay, see, okay, if we can go this pace, that's great for the class. Okay, let's see. Okay, how about this? This one is lightly tricky. It's not very tricky, but let's see. Let's see. This one, how about this? Okay, how about this problem? Okay. This one, I don't have the cache. Okay, I'll do one thing, guys. It's easier this way for me to write it down, I feel. 1 second, ma. Give me a minute. Where is the other? Oh, yeah. Okay, I have it here. One second, guys, I'm just arranging. Okay, so that's good. Okay, in this situation, right, which one did I give you? Okay, limit x tending to 2 minus f of x exists. Okay, limit x tending to 2 plus f of x exists. Limit x tending to 2 f of x exists. So this is 1, 2, 3. A is 1 only. 2, B is 2 only, or 2 only. C is 1 and 2 only. D, you have to pick one. These are just confusing because of the way they are written, but you can do it. 1, 2, and 3 are true. Go ahead, guys. A, B, C, or D? You got it? Are you able to do? I just saw one answer. I'm waiting. That's okay. Take your time, but let me know. Krish, I'll wait for your answer. Did you get it? Hey, yeah, I got both answers. Okay. Both of you, okay. So what was the answer, ma? You have given the answer. That is, answer is, have you given it a C? Correct, right?
Yeah.
Okay.
Yeah.
Okay, nice. Okay. Let me give you a couple. That is difficult. Okay, how about this? You know about the greatest integer function now? Do you know about the greatest integer function? Do you know about the greatest integer function? Let's see. This represents a greatest integer function. Do you remember the greatest integer function?
No.
Yes, no, anything is okay for me, guys.
No.
Okay. How about you, Krish?
No, I don't think so.
Okay. What is, we studied this in pre-cal. Greatest integer function is, let's say the greatest integer function. What is the greatest integer? 2.7 is given. What is the greatest integer function? The greatest integer that is less than that value. So this will be equal to a 2. What is the greatest integer function? When I have this function, what is the value of this function?
1.
1. When I have this minus 0.5, what is the greatest integer function? Tell me.
0?
No.
Is it 1?
Negative 1.
Okay, ma. See, the greatest integer that is less than this given value. Makes
Negative
sense?
1.
Yeah, negative 1. You got it? Krish, did you get it?
Yeah.
Okay, Krish, if you have not gotten it, I'll tell you. This is minus 1. Minus 0.5 is here. The greatest integer that is less, so left of the number line you need to go. What is the first integer that you
Oh,
come across? You got it?
okay. Wait, why do we have to go left though? Because it's a negative.
Yeah, it's a negative, but the greatest integer that is less means you have to go to the left, right?
Okay.
You see what I mean?
Yeah.
How about the greatest integer minus 27.3?
Negative 28.
Negative 28. You got it? Krish, did you get it?
Yeah.
Okay, good. So, you know what is the greatest integer function now. Now, can you evaluate this limit? Remember, guys, the greatest, see, the greatest integer function, I want you to know the graph because okay, when you look at it, right, at 0, right, at 0, right, what is the greatest integer? 0, that we know. Okay, 0.1, what is the greatest integer function of 0.1? 0, right, ma?
Yeah.
Yeah. Again, 0.2, 0, 0.3, 0, 0.4, 0, 0.5, 0, 0.6, 0, 0.7, 0.9, 0. Till 0.9 it will be 0. But at 1, right, what is the greatest integer function of 1? It's a 1. You got it?
Yeah.
So this is a whole here. Now 1, 1.1, 1.2, 1.3, 1.9, till that it will be 1. But at value 2, what happens? What is the greatest integer function of 2? 2, right? This is like a step function. Do you all remember this or no? Have we done this or no? Not really?
I can't remember.
Okay,
I don't
have you,
remember.
Krish, have you done it at school?
I don't think so.
Oh wow. Actually, I don't think I did it with you guys too. That's what I remember. But I always remember your brother did it with. I did it with your brother multiple times. So the honors the AP pre-calc swallowed it. I feel. Okay, first let's discuss that then. I didn't realize it. Okay, this is called the greatest integer function. You should know this, guys. But this current algebra 2 kids, I did teach them before even they came to pre-calc. Okay, so here for some reason, maybe I also don't remember discussing with your group. Here, greatest integer function means integer less than the given. Meaning the greatest integer less than the given value. So now, what is the greatest integer function for 2.5? What is the greatest integer function of 2.5?
2.
Greatest, yeah, 2. Because the greatest integer that's less than 2.5 is 2. Now, what is the greatest integer of minus 3.5?
-4.
Yeah, you got it. Now, what I'm saying is, let's plot it into a graph. What is the, let's say the x and y values, we'll plot it into a graph and see, it'll be very different. 0, we'll do it from 0, 0.1, 0.2, like that, 0.9, and then we'll do for 1. What is the answer to this? What is the greatest integer value of 0? 0. What is the greatest integer value of 0.1? 0.
0.
Yeah, 0, 0. What is the greatest integer value of 1?
1.
1, 1.1, 1.2, 1.5. Everything will be 1 till you go to a 2. Makes sense? So let me first plot this. 0 is a 0, 0.1 is a 0, till 0.9. At 1 it bounces up. So till 1 it continues and then it becomes a whole. At 1 it becomes this. Makes sense? So this is highlighted. This is thick. Now from 1 to 2, what happens? It continues, but at 2 it becomes a whole. At 2, what happens? It becomes a 2. Make sense, guys?
Yeah, I think now I'm remembering it. They like went over it at the beginning of the school year like once and
That's
didn't
the
do
feeling I
anything.
get. Yeah, I thought Krish school might have gone over it, is what I thought. Because in honors pre-calc, it's a big thing. Big thing means we cover transformations of this as well. That's what meaning. AP pre-calc, they gave the name and dumbed down the syllabus completely, and I don't cover it because pre-calc does not cover it. You see what I mean? But these are extras that are taught in some schools, which is better for you guys. But it's okay. If you've forgotten, it's okay. So this is also called a step function. Parvini, do you understand how this graph comes?
Yeah, I'm just a little confused on the part. So like, we go on the 0 until it reaches 1,
Yeah, ma.
and we draw
Okay, one thing,
openings.
Parvini. See, x and y values. What is the greatest integer function of minus 2?
-2.
Minus 2. What is the greatest integer function of minus 1.9, minus 1.8? Like that, it goes till minus 1.1, minus 1.0. Then again, minus 0.9, minus 0.8. Like that, it goes till minus 0.1, and then it goes to a 0. There is no, then it goes to 0.1, 0.2. Like that, it goes till 1. So let's find out the values. What is the greatest integer of minus 1.9?
-2.
Minus 2. Minus 2. Here it's a minus 2. Here it's a minus 1. Here it is a minus 1, minus 1, minus 1, and then it's a 0. Then it will be, what is the greatest integer function? Huh?
0.
Sorry.
0, 0. 1 becomes a 1. So it's like x and y values I'm plotting in a graph, ma. That's all. Minus
I
2.
got that part onto. I didn't get the part where you draw an open circle and then a
Yeah,
closed.
yeah, we'll see that. Okay. Minus 2 is a minus 2. See. It goes on. Right, ma? It's all dots. So I can connect them. Correct?
Mhm.
Correct? At minus 2. Oh, what I am drawing. Sorry, ma. Minus 2 is a minus 2, right? Yeah, it goes like this, like this, like this, like this. It goes. But at minus 1.0, what happens? It becomes a hole. We are at 2, right? So we are minus 2, right? We are putting a hole, but then the actual is defined here. You got it?
Mhm.
And then it goes till here, but at 0, what happens? At 0, it's not a 1. At 0, it's a 0. You got it?
Mhm.
So there is a hole at the right for every step. Make sense?
Yeah.
Okay, now we go back to our question. What was our question? If this represents the greatest integer function, limit x tending to 0 minus 2 by this will be equal to what? Wait a minute. Did I give you the full question? Yeah. Will be equal to what? I want you guys to try. You don't need options. What is the answer? That alone tell me. Come on, guys.
Is it -1?
Negative?
-2, sorry. -2.
Negative 2. Parvini, are you getting it?
Yeah.
You're getting it?
Yeah.
When x tends to 0 minus, right? When x tends to 0 minus means what, Parvini? It is going to be a minus 0.1, correct? What is the greatest integer function of minus 0.1?
-1.
Negative 1. So this you can substitute with a negative 1. Answer is 2 by negative 1 is a minus 2. Make sense?
Yeah.
Okay, that was good. Okay, now what other questions I had? I have more, but I don't know. Let's see. Can I enlarge this? I'm wondering. Yes, I can. Great. Okay. So let's see for this graph. Okay, for this graph, what did I do, guys? For this graph, for these answer options, you just tell me for the function f of x, which of the following is true. For the function f of x, which of the following options is true? Can you tell me?
Should we send in chat?
Yes.
I sent my answer.
Oh wow, that was fast, Amma. Parvini, do you have the answer? That's right, Krish.
Miss Priya,
Yeah.
when it means f of x is continuous for all x.
What it
Oh wait,
means?
never mind.
You got it?
Yeah, it's
Okay.
E, right?
Good. Yeah. Good job. Okay. So I was doing I'm losing track. Yeah. Okay, I think this is good enough. Okay. can we go into analytical limits? Okay. Now, see, as we did, right, we did only graphical limits. If you want, I can give you one more problem as a part which I have given you as homework. One more question we can do and then we'll move on, okay? Limits graphical, yes. Wow. I don't want you to draw now. So let's see. One easy one, maybe. This is a good one. Why don't we try this one? You're just going to quickly tell this one and then we'll move on. Only based on graphs. After this, we'll move on to analytical graphs.
Miss Priya, do you want us to say it out loud?
What, ma?
Do you want us to say it out loud or put it in the chat?
Yeah, you want anything is okay. Whatever you guys want. Go ahead. You're going to shout out or what do you want to do? I'm okay with either way, ma. Anything works with me. It's a small class. You can take liberty. Go ahead.
I'm typing my answers. I'm almost done.
Sure. Even if you make mistakes, it's not matter at all. We will try to complete. See, AB is pretty doable through the year and all. So, we'll see if I can accommodate any BC topics as well. I'll accommodate. Minus 2, 4, minus 2, minus 2, minus 2. Wow, nice, Krish. Did you get it, ma?
I'm almost done typing.
Yeah, take your time, no hurry. Okay, we'll go to analytical graphs, analytical limits after this. Krish, last year whatever we did, right, how did it adhere to AB calculus? It was very adhering or how was it?
As in, like,
What we did in this class, right, did it adhere to your AB pre-calc
oh,
exam and stuff at school?
yeah, it did. Maybe there was like some things like here and there that were extra than that we didn't do in class, but like mostly it was what we did in class.
I see. I see. There were certain things that you did at school extra and some things that we did extra here, is it?
Um,
How was it? Meaning, I really want to understand
I
so that.
think it was like perfectly fine.
Oh,
I
I
think
see.
I did really good. And
Okay.
I got like a 99 in my class.
Oh, nice. In your pre-cal class, huh?
Yeah. The first semester I got 100, the second semester 99.
Oh, nice. Okay, cool. Okay, great. Parvini, I'm checking your answer. No, I just want to know because see, when I match up and take the topics, right, I just want to make sure I didn't leave anything. Honestly, to be honest with you, that's what I wanted to know. Got
Yeah,
it?
it was covered. Yeah.
Okay. 4 minus 2 minus 2. Your class went faster, right, Parvini?
Huh?
Your class last year went faster, right, at school?
Yeah, they went a little faster.
Yeah, a little faster, and you have to catch up, right? You have to fill the gaps, right? Here.
Yeah.
Yeah, I know. We'll see. Okay, this year I don't want to be like that. Let's see. Otherwise, also I'll fill the gaps and make sure you're covered for your exam. Okay, you will take the AP exam this year, right, Parvini?
Yeah, I'll take it this year.
Okay, good. Okay, so we are done with um, Okay, I will post the homework, but please do the homework. Okay, now we'll go to analytical limits. Analytical limits. These are, if you understood it well, it makes it so much easy to get those 10 or 12 questions. Okay, now 1.2. Okay, so okay, this one, guys, you're going to be given an algebraic expression, whether it is a rational function, whether it is a polynomial, whatever be the function, right? There are some usual ways of solving limits. Okay, when you're given an algebraic expression, there's a proper way of solving limits. Let's see. Okay, one is, if you're given an algebraic expression, let's say they're asking you to calculate this. What do you do, guys? This, the analytical limits is nothing but you're going to be given some functions. Okay, you're going to calculate the evaluate the limit. That's all. Okay, but time and again we have been doing this, and there are some set methods. One is you can directly substitute the value. Directly substitute. Okay, or second one you can do is factor cancel. If it is a numerator and a denominator, right? So let's say you have this factor cancel, right? Here you are factoring and cancelling and then substituting. Otherwise, right, if you're going to have root 2 minus x, here what do? It's very hard, right? You have to rationalize the denominator. You know what is rationalizing the denominator, right?
Yeah.
Okay. Then in case if you get, when you substitute, when you plug in, sometimes you will end up with a 0 by 0 or infinity by infinity. These are cases where you need to apply something called L'Hospital's rule. Okay, so basically for directly finding out limits, right, you are going to directly substitute the x value. If that doesn't work, factor and cancel. Rationalizing the denominator is the third way. The fourth way, you will use the L'Hospital's rule. Can I move on?
Yeah.
Okay. What do you think you can use for this? Sometimes it's very easy with directly substituting it. Okay. If that's easier, if that comes out, that's the easiest way. How do you do this? Limit x tending to minus 1, x square plus 2x minus 4. What is the answer, guys? You can yourself tell. It's easy.
For the first one, we can substitute it.
Yes. So what is the answer?
It's a -5.
Yep. So you directly substitute. Second one?
Can you also substitute?
Yes, you can also substitute. And
It would be 2.
2.
yep, 2. Do you know how to do it in a calculator? Do you know means you're going to type this as a function and then go to math, calc, x value. If you substitute, you'll get the corresponding y value. That's what I'm asking. Do you know how to
Yeah.
do that?
I know how to.
Okay, Parvini, do you know how to do that?
I think so.
Okay. See, but please, guys, that is important. Meaning, you have to be able to type this function and then go to math, calc. When you type in the x value, it should give the y value. How about this? Which process you'll use? You're going to use and tell me the answer, guys. I'll wait. Not a hard one, these are. Once you really understand the hang of it, these are very easy.
I forgot what the other ones were.
Okay.
Miss
No
Priya,
problem. Yeah, tell me.
After, can you show me how to type in the limit into the calculator?
Oh, no. You don't have to find the limit in the calculator. Wait. I'll help you. Direct substitution. See, when I change the screen to calculator, this will go factor cancel and then rationalizing, then indeterminate forms like 0 by 0, infinity by infinity. If you all get that, then there is a rule for this, L'Hospital's rule. Any questions? Can I erase that?
Yeah.
I got it.
Okay. Um, what, Parvini? You wanted to see the calculator, right, ma? Okay. Now, um, TI 84 Calca. What is that? 1 second, guys. Wait, I'm not able to type anything. Why? TI 84 calc.com. Okay. Parvini, can you tell me one function, ma? Something we discussed, right? Anything we discussed. You don't remember? I can check. You want me to check?
Yeah.
Yeah, no problem. Extending to 2, square root of 3x minus 2 we discussed. Extending to 2, square root of 3x minus 2, right? Krish, just wait for us for a minute, okay? This is what I asked you to calculate, right? Anything you can just type in. Okay, Parvini, this is just one example I'm going to do. Here, y equal to, you are just going to put square root of 3x minus 2, right? Where is the square root? Square root of 3x minus 2. 3x. Oh, I need to use this x. 3x minus 2. Make sense, Parvini?
Yeah, so we don't need to type in the limit thing.
No, graph. You got it?
Yeah.
Now what do you do? Even I forgot. Calc. Yeah, value. Value. X equal to, you will type 2. You got it?
Yeah.
Very easy, right?
Yeah.
Yeah, pretty easy. Just that you need to type the x value. But you need to remember all of these that you can do this. Many a time kids will forget. Okay, now I really want to come back. Come back in the sense, stop share. Share this. You're going to do this. So can you do this one for me? Find the limits for 3 and 4. Evaluate these limits. These are analytical limits, no graphs. See, the thing is, it's very easy to graph them, right? And then say math calc, find the 0, x equal to 0, find the values. You can do that. But is there any other way? Meaning, you're not going to be given graphs or anything.
I sent my answers.
Oh, that's good. Was easy, right, Krish?
Yeah, after I saw like the other options.
Yeah, makes that's right. That's 5:15. Did you get ma?
I didn't get any value in the calculator.
What ma?
When I put it into the calculator, I didn't get any value for number 3.
Number 3. No problem. I want to see what you did. Ayyo. Don't close it. Let me finish and come. I'll see. So here, guys, limit extending to 0. I'm doing it for you, Parvini. You can take out x as common, right? Factor and cancel. You see, 4x minus 5 divide by x. X and x cancels. Substitute x equal to 0. So you get 0 minus 5 equal to a minus 5. Make sense, Parvini?
Yeah.
And then the second, the fourth one, you are going to see, this is where factorizing comes into picture. 2x square minus 14, right? 14, 7 2s are 14, 14 and 1, right? Plus 14x minus 7 divided by x plus 7. So you get 2x as common, x plus 7 and minus 1 is common, x plus 7 by x plus 7. So now let me rewrite the problem. Limit extending to minus 7, 2x minus 1, x plus 7 divide by x plus 7. Cancel. Now substitute 2 times minus 7 minus 1 is minus 15. Make sense, ma?
Yeah.
Oh my gosh. 1 second, ma. 1 second. My battery is gone. Okay, that's okay. I think I'll be able to manage. Do you guys get it? Parvini, did you get how to do that?
Yeah.
Yeah. Now, there's a lot more. Okay. Why don't we continue the rationalizing next week? Is that okay? Meaning analytical limits, we have just covered what to say. Analytical limits we've covered maybe 50%. Can we do that? Can we do the next 50% next week?
Yeah.
Okay, after that, once we cover analytical limits, graphical limits, we'll do some more AP style, AP exam style questions on analytical limits, and then we'll go to what is that? Asymptotes and continuity. Okay, horizontal, vertical asymptotes you already know. Please revise and come if you want to. The homework will only be on graphing limits. Limits using graphs. Okay, any questions to me?
No.
No.
Okay, but please do the homework, guys. It is so useful. You can have a heads up in class. Okay.
Okay.
Okay, guys. See you all next week, guys.
Thank
Bye.
you.
Thank you.
Bye,
Priya,
ma.
I wanted to ask you,
Absolutely, I'm here.
for Izzy, I wanted to ask if you sent the welcome email out or like if I didn't get it. For
Is